Hello, we are from Group L and we are going to present on Group Project KNP 4073. Now, I am Nicholas Udiana Badan with matrix number 82771, while my other two members are Jaden Caleb Sensen 82614 and also Alistair Brian Anna Anthony Glees 82393. Firstly, I will be talking about introduction and also background. Company Z is a cake manufacturer that has been operating for about 20 years, mainly supplying local supermarkets and hypermarkets. Over time, competition in the food manufacturing industry has increased, and customers now expect consistent quality and reliable supply. Recently, Company Z received a major contract to export cakes to the Middle East. This contract requires large production volume and strict quality consistency, which is difficult to achieve using their current semi-manual production system. Because of this, Company Z is planning to build a new factory and adopt full automation. Automation will allow the company to increase capacity, improve efficiency, and ensure consistent cake quality suitable for international markets. Next, I'll be talking about problem statement and objectives. Firstly, what is the problem statement? The main problem faced by Company Z is that the existing production system cannot support mass production efficiently. Manual handling introduces variations in cake weight, texture, and appearance, which affects product consistency. In addition, the company has limited experience in automated mass cake production, making it difficult to meet export quality standards without a structured system. Therefore, the objectives of this proposal are to improve product consistency, enable large-scale automated production, and establish a reliable quality monitoring system that can meet national food safety and quality requirements. Moving on to the automation in food manufacturing, I will be talking about the benefits and the common uses in bakery industry. In modern food manufacturing, automation is widely used to improve efficiency, hygiene, and consistency. Automated systems reduce direct human contact with food, which lowers contamination risk and improves food safety. In the bakery industry specifically, automation is applied in processes such as ingredient weighing, mixing, baking, cooling, and packaging. These systems ensure that production parameters such as temperature and time are controlled precisely. For a company like Company Z that is expanding into export markets, automation is essential to maintain consistent quality while increasing production volume. Now, what are the importance of quality monitoring? Quality monitoring plays a critical role in automated food production. It ensures that every cake produced meets the required standards for appearance, texture, weight, and especially safety. Without proper monitoring, defects may only be detected at the final stage, leading to increased waste and higher costs. Early detection allows corrective actions to be taken immediately. For export products, quality monitoring is also important for compliance with international regulations and for maintaining customer trust in overseas market. Let's talk about online monitoring. What is online monitoring? Online monitoring refers to real-time inspection carried out during the production process using sensors and automated system. Temperature sensors are installed in baking ovens to ensure uniform baking and to prevent underbaking or overbaking. Machine vision systems use cameras to inspect cake color, shape, and surface condition, allowing defective products to be identified instantly. Weight sensors are also used to ensure that each cake meets the specified weight, while moisture sensors help maintain the desired texture and shelf life. All monitoring data is collected and stored in a centralized system, enabling immediate response to any deviation from set standards. Now, let's take a look on offline monitoring, which is also a laboratory testing. Offline monitoring complements real-time monitoring by providing detailed analysis through laboratory testing. Samples are taken from each production batch based on a predefined sampling plan. Physical tests are conducted to evaluate cake texture, color and size, while chemical tests verify moisture and ingredient consistency. Microbiological testing ensures the cakes are safe for consumption, which is especially important for export products with longer shelf life. Packaging integrity tests are also performed to ensure that seals are secure and labels are accurate, protecting the product during transportation. Now, what are the benefits of the proposed monitoring system? Now, the proposed monitoring system offers several benefits to Company Z. Firstly, it ensures consistent cake quality by controlling key parameters throughout the production process. This is because early defect detection reduces waste and rework, leading to lower production cost. Data recording also provides full traceability, which is essential for audits and customer assurance. Overall, this monitoring system strengthens Company Z's ability to meet international standards and successfully expand into the export market.
Hello, my name is Jaden Kalib Samson with the matrix number of 82614. So now we're going to look at some manufacturing methods. And the first one is going to be group technology, which is classifying the cake products. So from this, it organizes the products to family based on similarities. So if you can see the cake classification, this is going to be the size, which includes small, standard, and large sizes, and it's uh, going to be the flavor, which includes the chocolate flavor, vanilla flavor, and the fruit flavor, and it goes back down to the type, which is either sponge, layered, or frosted. So now we're going to look at the benefits. So the benefits of this manufacturing method is it's a streamlined production schedule. It reduces the recipe change over time. Other than that, it standardizes the ingredient handling, and most importantly, it maintains the quality consistency across product families. So now we're going to look at cellular manufacturing. So this means it's going to be split up to a few cells. So this is for the layout for the cake production. For the cell one, which is the dough mixing, it will involve the automated weighing and blending. For cell two, is going to be baking, which is where the ovens are programmable with precise control, and moves down to cell 3 or goes to cell 3, which is the cooling. So this is where the conveyor tunnels will be controlled. Will have a controlled airflow to cool the cakes after being baked. And cell 4, which is the packaging, was the last part. This is where the automated cutting, wrapping, labeling, and sealing happens. So the benefits of this cellular stuff is it reduces the material movement. Other than that, it shortens the production flow. And other lastly, it produces fewer bottlenecks. So it produces smoother, faster, and more efficient operations. So now we're going to look at the third manufacturing method, which is the cellular manufacturing system, which is FMS, or in other words, this is where to handle cake variants. So it is a programmable machinery and automated handling for quick changeover. So the applications, it adjusts the baking times and temperatures for different recipes. It can switch molds and portion size easily. So if the industry or the company wants to switch molds and portions of the cakes, it can be done easily. and it adapts packaging to different boxes and boxes size and labels. So the benefits of this manufacturing method, it's an efficient production. Multiple cakes can be produced efficiently. It produces minimal downtime, and it's highly responsive to diverse customer demand. So if there's like a specialized cake or a cake that or a customer that wants a cake done differently, this manufacturing method can be used. So now we're going to look at the quality assurance. So for this situation or for this scenario, or in other words, for this project, we're going to use the Taguchi method. So the Taguchi method focuses on robust design. It minimizes variations and it optimizes the parameters. So variation in here, it means it's either the variations in types of cake or how the cake is designed or how the cake is produced. So the factors affecting the cake quality, some of the key factors, in other words, is flour to sugar ratio, the baking temperature, mixing time speed, the moisture content, and it's either the cooling duration. So for the DOE or the design of experiments, it's an L9 orthogonal array. So the flow ratio can be either low, medium, or high. So each flower ratio has a baking temperature of different variations. For example, if it's low, it's going to be 170 degrees Celsius. For medium, it's either going to be 180 degrees Celsius, and for high, it's either going to be 190 degrees Celsius. So it's going to go down to the mixing times with a variation of 5 minutes, 7 minutes, or 9 minutes, and the cooling duration can be either 10 minutes, 15 minutes, or 20 minutes. So the benefits of this, it can identify the optimal conditions. It improves consistency and reliability. It meets the international quality standards for food or for the cakes. So now we're going to look at the some of the inspection techniques. So inspections are very important to ensure quality of the produced product or the produced in this case it's produced cakes. So the first inspection is the visual and physical inspection. So this can be done from machine vision checks, color of the cakes, the shape of the cakes, the surface of the cakes, surface texture. I'm sorry, and the analysis for softness of the cakes. So this is to ensure if the cakes produced are up to standard, up to quality to be sold. So the other next is going to be the weight checking. So the weight checking can be used using a weighing scale. So automated scales can verify batter and final cake weight. This is to ensure every cake is produced according to its recipe, and also reduces the risk of resource losses. So moving on to the packaging inspection. This can be done by looking at the seal integrity test and label accuracy checks. This is to ensure the standardize of labeling and packaging. Now we're going to look at the foreign objection detection. So it's an inline system safeguards against contamination. This can be seen by using a metal detector. For example, maybe there's some metal parts or some metal chipping that happens to be in the cakes. So a metal detector or a foreign object detection method can be done so it's safe to eat and to reduce the risk of jeopardizing the quality. So the benefits of these inspection techniques, it ensures safety and consistency, which is very important for the consumers. It is in compliance with the HACCP and ISO 22000. And lastly, it builds customer trust through guaranteed quality, which is important for the economic drivability of a company.
Finish with the previous part. Now we're moving on to the next part or the next chapter, which is the automation approach. Under this chapter, it consists of a two automation approach, which is centralized approach and a decentralized approach. Under the centralized approach, to begin, centralized approach is an automation systems that use a single primary controller, in which it may includes programmable logic control (PLC) or a supervisory control and data acquisition (SCADA). This approach enables to manage data and commands for all linked units and also able to control the whole production process such as mixing, baking, and packaging. Centralized approach has two types, which is the first one is the totally centralized, and second one is the hierarchical centralized. For the totally centralized, one controller handles all process, while for the hierarchical centralized, top controllers supervise several lower level controllers. Settled with the previous part, now we're moving on to the next part or the next chapter, which is the automation approach. So for the automation approach, it consists of a two approach, which is the centralized approach, and the second one is the decentralized approach. So under the centralized approach, it is an automation systems that use a single primary controllers. It may consist of it may includes programmable logic controller (PLC) or supervisory control and data acquisitions (SCADA). Centralized approach also able to manage data and commands for all linked units. It is also able to control the whole production process such as mixing, baking, and packing. Centralized approach consists of two types, which is the first one is the totally centralized, and second one is the hierarchical centralized. So for the totally centralized, one controller handles all process, while for the hierarchical centralized, top controller supervise several lower level controllers. Under the centralized approach, in the cake productions, human machine interface (HMI) monitors and adjusts parameters in real time. It also ensures consistent product quality and unity of management. This centralized approach also have its few advantages and also limitations. So for the advantages, the first one is it enables consistent data flows and unified controls. The second one is the easier troubleshooting and maintenance due to the fact that it only consists of one control system. The third one is the lowest setup cost, which in which it consists of only few controllers. And the last advantages is is simplified data logging and quality tracking. So for the limitations of centralized approach is the first one is the single points of failure. For example, to explain, if the controller fails, the whole line stops. The second one is the limited flexibility for future expansion, and the last limitation is the possible performance reduction if the systems is overloaded. So for the second part or the second automation approach is the decentralized approach. It consists of several local controllers, manage separate processes, which includes mixture, oven, and packagings. Although these controller functions independently, industrial communication network allows them to exchange information. There are also two types of decentralized approach, which is the first one is the fully decentralized, and the second one is the partially decentralized. For the fully decentralized, each units work autonomously but share data. And for the second types, which is the partially decentralized, local units report to a supervisory controller. Similar to the centralized approach, decentralized approach also has have its advantages and its own flaws. So for the advantages, it is consists of a greater flexibility and scalability, in which it is easy to add new production modules. The second one is the fault tolerance failure. To explain, failure in one area does not stop the entire productions. So for the disadvantages, the first one is the higher complexity in production, in coordination and troubleshootings. It may require multiple PLC and communication link, in which it costs or it may influence the higher cost. The third one is the consistency in quality. It's much harder to maintain without advanced synchronizations. Now is the recommendation part. So for the recommendation part, companies that must choose to use or to apply either centralized approach or decentralized approach. So after taking some considerations, companies that must or have chosen an approach which is the centralized system approach due to some few factors. One of the factors is it is much simpler and easier for a small company like Company Z to enter full automations. The second one is it ensures uniform care quality across all stages, which is also critical for export markets. The third one is it is much lower installation and maintenance costs. The fourth one is the risk of single point failure. It may be a risk of a single point failure. However, it can also reduce through backups and regular maintenance. The last one is uh, it involves minimal technical workforce required compared to the decentralized approach. Settle with the previous part. Now, now we're moving on to the next part or the next chapter, which is costing. Under this chapter, it consists of a few elements, and one of them is the equipment cost, installation and training costs, and many more. So the first one is the equipment cost. Under this equipment cost, it consists of the estimated cost of few machineries and sensor items, such as automated mixture and ingredient wager, with a price of estimate 60,000 ringgit, conveyor systems, estimated price to be 50,000 ringgit, a programmable baking oven, estimated price 90,000 ringgit, weight and moisture sensor, estimated price 10,000 ringgit, and many more. So to total up, the net price or the total price for the equipment cost is estimated to be 47,000 ringgit. Second part is the installation and training cost. For the For the installation costs, it involves mechanical setups, electrical wiring, control system integration, and testing. For the mechanical installation and alignment, it is estimated to be 25,000 ringgit. For the electrical wiring and control panel, it is estimated to be 15,000 ringgit. For the PLC programming and software integration, it is estimated to be 20,000 ringgit. And lastly, for the installation cost, the system commission and testing is estimated to be 10,000 ringgit, in which the total price is 70,000 ringgit. Next one is the training cost, in which training cost is needed due to the fact that it ensures staff can operate and maintain the system safely and efficiently. Under the training cost, it consists of operator training, which approximately 5,000 ringgit, and also the maintenance training, also 5,000 ringgit. And for the total price, it is 10,000 ringgit for the training cost. The next costing is involved the maintenance cost, which is measured annually. So under this maintenance cost, it consists of a preventive maintenance consumables. Under the preventive maintenance, it is sensor checks, calibration, and motor inspection, with an estimated annual cost to be 12,000 ringgit. Also for the spare part, it is the PLC module, belt, and sensors, with an estimated annual cost to be 8,000 ringgit. And for the cleaning and consumables, it is a lubricant, filter, and cleaning materials, with an estimated annual cost to be 8,000 ringgit. So for the total price, it is estimate it is estimated that the maintenance cost and for an it is estimated that for an annual maintenance cost to be 22,000 ringgit. The next part under the costing is the operational cost change, which includes the labor cost. Under the labor cost, we evaluate and we analyze the labor cost before the full automation is introduced, and also the labor cost after the full automation is introduced. Before that, we make an assumptions for the before full automations. So the assumptions for the before full automation is introduced is that an amount of workers that works in for the productions will be working in a single shift, in a single shift 12 hours per day, and will be paid 6 ringgit and 50 cents per hour in accordance to the government's mandate minimum wages, which is minimum monthly wages is 1,700 ringgit. To explain further, as I mentioned earlier, for the before full automation is introduced, it consists of 8 production workers, 2 supervisors, and 2 quality inspectors. The total labor cost for monthly is 31 is estimated to be 31,200 ringgit, and for the annual labor cost is 374,400 ringgit. After the full automation is introduced, the number of workers is set or is observed to be reduced. It consists of only 2 operators, 1 maintenance technician, and 1 quality control officers. For the monthly labor cost, it is estimated to be 12,400 ringgit, and for the annual labor cost, it is estimated to be 149,760 ringgit. Based by observing 2 conditions, we can conclude that the labor saving is estimated to be 234,640 ringgit per year. Now, the second part is for the operational cost change is the utility and waste. Before we start, we make an assumptions for the company Z, which is the company Z is located somewhere in the peninsula Malaysia, and due to that, the electricity usage by the company Z is being charged by the Tenaga Nasional Berhad. So, according to Tenaga Nasional Berhad tariffs, newest tariff, it is said that the newest tariff for the electrical usage is 0.454 ringgit per kilowatt hour. Hence, the estimated electrical usage cost is 330 kilowatt per day, which equivalents to 53,935 ringgit per year. The waste reduction is being deducted up to 15 ringgit per year, and the reject reduction is being deducted to 10,000 ringgit per year. Therefore, the net utility saving is equivalent to 5,000 ringgit per year. Finally, the last part of the costing is the cost and benefit analysis. Under this element or under this part, which is the cost benefit analysis, we evaluate few things, which is the total investments and also the net annual savings. So for the total investment, it is said that it is said to be the company that has invest as much as 527,000 ringgit for the completion or for the startup of a new business with a full automation. Secondly, we take a look at the net annual benefits. The net annual benefits is basically the sum of the labor cost saving plus the sum of the labor cost saving and the net utility saving, and will be minus with the maintenance cost. And the net annual benefit is calculated to be 207,640 ringgit per year. Lastly, we take a look at the payback period. So to begin, payback period is the amount of time needed for an investment to produce enough saving or return to cover its initial cost. To further explain, it is basically the amount of time needed for the company Z, which has already invest an amount of money which is equivalent to 527,000 ringgit, and it need amount of saving and return to cover its initial cost. So for the payback period, it is calculated it is calculated by dividing the initial investment with the net annual benefits. And for our case, for our scenario, the payback period is set to be 2.5 years. And according to the payback period, it tells or it tells us that the investment will be recovered in 2.5 years, showing strong financial feasibility.